will be amazing. Okay.
I believe it should start recording. Yes, we are recording.
I heard a notification. Okay, wonderful. Then let's start the technical walkthrough call. Gentlemen, honestly, feel free to start whenever you want and whatever place of the code you want. The main purpose of this call, of course, is to cover the main functionalities of your code that's going to be in scope for the contest, so that white hats can watch this recording, can understand where they should hunt, where they should not hunt, or maybe which areas of the focus are the most important for them. You can go like as deep as you want, essentially. You can cover the code high level or low level. I'd recommend not staying here longer than 1 hour, because this is usually the time that whiteheads, like tend to watch these recordings. Maybe 1 hour and 15 minutes. That's also fine. Yeah, feel free to start, share screens, slideshows, anything.
Okay. All right. I don't really have any slides to go over. I think the document that we kind of kicked around before, let me just take a look at that. I know that one of the things I wanted to call attention to was the peering code, since that is, an aspect of the code that folks are going to be punching a hole in their network. And let me share my screen and
Honestly, if
expose.
you can just share the code itself, that's gonna be, yeah, that's already amazing. Like that's more than enough. Yeah.
So for instance, P2P networks, P2P services, default P2P networks, any of these type things here. If we look in, there's a submodule here. Okay, so maybe just a high level overview of Besu and the code base and how it works, right? It's a Gradle project. It has lots and lots of, I shouldn't say that many. It's got about a dozen or so sub projects, right? That kind of break things up. Each one of them, if you know Gradle, has its own project, et cetera, et cetera. And so some of these might actually be easier to target, right? So here's in the Ethereum subproject, that's where you're going to have things that are kind of protocol specific or defined by EF specs. This is where you're going to have things like P2P because it's dev P2P, right? There is a spec for that. There's a version of it that runs. So that's going to be implemented in this module. What else do we have here? Core is where you're going to have a lot of your protocol related things. EVM tool is a accessory kit, I think, for testing an isolated EVM. So if you wanted to fire transactions at it or set it up with a particular state, there's a tool here to facilitate that. It is documented as well. Let's see, what else we got? Serialization, that's always a fun area to attack, right? What kinds of weird packets can you craft? So this RLP package here would be where you would go to take a look at that. Maybe if you want to attack serialization, how things are encoded, decoded, etc. Yeah. The try and the Verkle try packages are more specific to our data storage. I wouldn't really expect anything interesting to attack there, just because it's all covered by a state root, but
Also not in use right now, right? Just in
yes, the Verkle try one is not.
anyhow. So
Yeah.
I don't think it's worth having it go there.
So Justin, I wonder, like before diving into the code itself and like functionalities, maybe you can cover like the project itself at a high level, like how exactly parts of the code interact with one another, and then we can maybe dive deep into some like some peculiar aspects that you feel should be highlighted.
Okay.
What would also be helpful is to know, what's the format of the attackathon typically? Is it kind of like a pen testing kind of thing? Is it more of a fuzzing type of thing, or what are the typical vectors? Like it's hard to kind of characterize what's a good place to attack or start and look without kind of knowing what the the strategy is going to be by the white hats?
Sure, sure. So, in a nutshell, the page, the attackathon page will go live on the Minify website, and it will contain links to all the assets in scope. So all the assets, all the contracts that Ethereum Foundation and all the adjacent projects will put in there will be there. And whiteheads will be able to review that code, look through it, and find one of the following vectors of attacks. So I just shared a link in the chat. This is Minify's severity classification system, which is the industry standard for attack paths and impacts. And one of the impacts that Ethereum and I think the program draft is still being finalized, so there will be some custom impacts. But some of the impacts will be present in the draft, and whiteheads may choose one of the attack paths and therefore exploit or not exploit the code. That's like in a nutshell what's going to happen. I can say for sure that all the impacts that you see right now on that page will be present in the attackathons page. So there will maybe some custom ones, but generally this is the direction where it's going to be. Does this answer your question?
Yeah, I think so. So it sounds like it's largely going to be like in protocol attacks and
right.
Okay. Not less like pen testing for node setups and things like that.
Depends on the attack path. Again, someone can develop something like very interesting and can not like test certain things. They're rather looking how to break them. Yeah, so a bit different here.
It could be Besu doing a SnapSync, and you are sending invalid data and check if the result of the sync is invalid in Besu or something like that. Yeah.
Yesterday, we were talking about plugins as potential spots. I don't know if we already brought that up.
Good
Okay,
idea.
so let's, so I have that in the notes. We will get to that. If we're asking for a general overview of the Besu code base, I can take a crack at it. I'd like other people to jump into and add things that we're not thinking of, but at a high level, it's a Java application. It uses Pico CLI to configure it, right? So that's one of the earlier, and if we think about it as kind of a loop, one of the early entry points into the program is providing configuration options, right? So you can provide stuff through the command line, through the environment, and config files. Besu will spin up a number of event loops. The Ethereum loop itself is single-threaded, but there are other multi-threaded aspects of it for handling like RPCs and some of the peering and things like that. We use a Vertex library for that. It is a asynchronous, I wouldn't call it reactive, but it's kind of a eventing and multi-threading toolkit. So that's kind of used under the hood to handle a lot of different things.
And by extension, Netty, because Vertex is based on Netty.
Great, yes. Netty is a networking stack that we're using for the P2P stuff. That's a good call out. What other general overview of Besu stuff am I not thinking?
I think what's novel about Besu as opposed to some of the other execution clients, most of the other execution clients, is that there's native components. So we have the RocksDB implementation that we use for storage. We use JNI for that because it's written in C++. A lot of the precompiles are written in Go or Rust or C++ or whatever. So there's native components to this. So I don't know if that's an interesting attack vector. You definitely would have to have local access to start attacking that vector, but that's definitely a difference between most of the other execution clients, is that we do a lot of foreign function calls.
Cool. As far as entry points are concerned, the main class is just besu.java. Where is it? What am I not seeing here? What are you trying to show there?
Yeah,
You mean
it's
you
okay.
mean Besu command, but maybe.
I'm in basic command, yeah. I wanted to show, I guess you're right, there it is right there. You were trying to click on it. So this is your main entry point here, but Amazian is right. Basic command quickly takes over and basically everything goes there. And this is a large complicated class, but it does a lot of the command line, I think it's parse, right? Let's just go here. This kind of gives you your outline of how it sets stuff up. No, it does not actually. Yeah, this is probably too low level, probably getting too low in the details. But these are the classes that you're going to want to look at to see how Besu gets started and where it spins off other things that would be interesting. So what Ade was saying is there's also a plugin framework where you can provide stuff in the local file system that Besu will spin up and it'll actually start running it. So that's a potential attack vector. Let's see.
Yeah, maybe Justin, if I can add something. So what is interesting with Besu command is actually the starting point. So when we start Besu, we have like this class that instantiates and starts all the services. This is how I understand it. So everything goes from there. We should have everything that is set up from Besu command. It's like it creates the tree of all the objects from there. So we have, for example, JSON RPC is actually started from there. So everything is started from this Java class. We have all the objects that are associated. We read the Genesis file from there, if I remember correctly. So we set everything from there. Then depending on what consensus algorithm we have, so depending on actually the configuration we give to the Besu command, basically what we read from the Besu command line, basically, we are going to have different objects that are that will have different state. Then maybe we are going to start an Ethereum mainnet loop, or we are going to do another consensus. But everything starts from Besu command. We read like the command line. We build all the objects that basically we need to start the Java, basically the process related to our use case. Then we have the JSON RPC that is started. Like this is an HTTP server that we can look at after to see if there is any surface attack there.
So these are the different services that he's alluding to here. So there's a JSON RPC. There's also an engine version of it. We support GraphQL. We support WebSockets. This is a mining server, which likely is irrelevant for most use cases, unless you're testing things on ETH Classic, right? That could be relevant.
I don't know if this is relevant, but one thing I noticed while working on the Genesis files is there doesn't seem to be any schema or anything like that that allows you to confirm that a certain config file is correctly formatted. So I don't know if that can pose security risk.
Sure.
Yeah, because you may have undefined set of states, maybe. So that's.
Okay.
That's very useful, guys. So to continue the mood here, it's like you of course know the protocol better than anyone because you designed it. But from like a hacker standpoint, imagine that they only have 5 or 6 weeks. So they'll be looking at the code. Let's say, what are the areas of the code that you believe they should focus on first, and then maybe second, and how they interact with each other, how they can better understand the interactions in like less time to report certain vulnerabilities.
Well, I'm not a security expert, but I would probably rank anything that comes in through the P2P layer higher than everything else, right? Because you have to punch a hole in your firewall to get on the network and to peer with the other clients on the network, and you have to accept what they're sending you. So I think that would be probably the most important thing for me to make sure was secure. After that, the RPC layer is an area where users may not follow our guidance, and maybe they expose these things, or maybe they make them a little bit too accessible. So that would maybe be the next thing that I would look at. The plugin vectors, I think those are interesting, but you need to have local access. You need to be able to write to the file system. You need to kind of already have some pretty dangerous access enabled to be able to exploit those. And then there's like the annoying things. I think Luis just mentioned, denial of service attacks, things like that. We do a lot of hardening at the EVM itself, looking for denial of service vectors and ways that people can craft completely legitimate transactions that are reasonably costly from a gas and transaction fees perspective, and yet exhibit, more strain on the system than they should. And that's an entire class of security issue that is probably, that's the majority of the things that we find out and react to and try to mitigate. It's those denial of service types attacks. For those, I think you're going to be in this package here, in the EVM package. That's the tightest loop in Besu as a system. That's the place where performance is the most critical. Specifically in like syncing scenarios, like any type of scenario where you have to replay a bunch of blocks and re-execute them to maintain or establish state. Those are the places where a denial of service is going to hurt the most, or one of those gas mispricings, let's call it. Those are the places that are going to hurt the most. And so, the EVM loop or mainnet transaction processor would be the places to start looking for those. So mainnet. This is a very central class to most of the things that we do, right? And these message frames, these are like EVM frames. So this is your contract into the EVM itself. So if you're inclined to look for these types of attacks, I would start here.
Got it. One other question that's usually raised by the community, is there any documentation that whiteheads can dig in that will be maybe provided within with the code? So any types of diagrams or just texts which are covering the protocol, anything like that?
I posted a link to this right here. I included that in the meeting chat. This is where all of that type of stuff would be. This is our development wiki. So all the developers that are taking notes or doing design work or drawing diagrams or any of that kind of stuff, that's all in this wiki here. I don't have any particular...
How up to date it is? How up to date it is, Justin? Because some projects, they share it and they're like, oh yeah, we didn't touch it for like a few months. Is it like really accurate?
It's not ancient. And I think you'll know just by looking at here whether or not it is, right? So
Yep.
The things that are more up to date will say last updated, somewhere nearby, but there might be like, you're gonna have to use your own discretion. There is some stuff this was just updated on the 3rd of October, right? So this is pretty accurate. This is pretty useful. Some of the things they might be out of date, but they might not be. This is a design overview, right? So might still be relevant because it's at a high level and it's not specific. So it's not the type of information that decays rapidly. Um, your mileage may vary, I think is my answer. I don't know. Has anybody else got an opinion on that? I'm doing too much talking here. What do you guys think?
I think the Bonsai documentation's way out of date. Kareem, didn't you publish a more recent overview of Bonsai that
Yeah,
might not be in Confluence?
yes, but yeah, as I said, it's not in Confluence, so I can share the link. I don't know if it's in Confluence, but uh, I can share you a link to the most up-to-date documentation regarding Bonsai. This is
I
this
think
one.
Bonsai is an interesting attack vector also because it's probably our most highly scrutinized portion of code. That was in January this year when we had an attack that was specifically targeting Bonsai. I think that would be an interesting target for attackers.
Gary, can you go a bit deeper into the structure of Bonsai and then the attack that happened? Like any useful information around this, maybe what exactly happened, if you can disclose it, of course.
Oh yeah. It's actually, I think that is in Confluence probably, or in the Hyperledger.
Where do you want to go? Do you want to share, or do you want me
No,
to?
that's okay. I'm happy with you driving. Thanks for doing that. I think there was a postmortem of the January. It was January 6th this year. I think you can just look for January 6th if you do a search. See if I can find it. Yeah, but at a high level, while Justin looks for that, at a high level, what Bonsai does is we really, in basically for Bonsai, we maintain a single Patricia Merkle tree, a single world state. That what we do is when we go from state to state, from block to block, we take a series of diffs. In effect, like when we apply a block, when we execute a block, that becomes a diff that gets applied to that single tree, and we log these diffs in trilogs. So for this single world state, when we go from block A to block B, we log those changes so that if we need to roll back, if there's a reorg, we can unapply that diff to roll back to state A. It's essentially what it is it's a diff-based single world state tree. So it gives us a lot of space storage savings over the other storage mechanism that Besu typically was using as its default, which was Forest. And that Forest saves all versions of all trees in effect. So you end up with a really, really large footprint on disk. Bonsai, though, because of the way we accumulate these changes during block execution, it's very tricky. It's especially when self-destruct was still active on the network. We could have code that would be metamorphic. You could deploy a code in a block, self-destruct that code in a block, redeploy that code via create2, and then destroy it again. And it just made for really tricky accumulator issues. And that essentially was what happened on January 6th. We had identified a problem with self-destruct in Bonsai. This actually, I won't go into detail on it because this does a pretty good job of describing exactly what happened. But that was basically a race to exploit this before we fixed it, and because we were fixing it in the open, and somebody knew about it privately, so they wanted to grief Besu clients ahead of the fix. But historically, Bonsai's been a very good differentiating feature for Besu. However, it's also very challenging code, very difficult code.
Got it. Thank you for covering it. I'd say while we're staying on topic of vulnerabilities here, one of the first questions in the technical walkthrough agenda that we had is about any findings that were identified during the audits. And as far as I remember, you wrote that there weren't any significant issues found other than known library vulnerabilities. Can you maybe cover this a bit? Because I also saw that you said that we have found more useful for finding issues is targeted fuzzing. Can you talk more about that?
Yeah, I think recently we had a fuzzing based find for the BN254 implementation, that's EIP 196, that there was an issue that was discovered just by an independent researcher who was fuzzing that particular precompile, and essentially they were just doing differential fuzzing between, I believe it was Geth and Besu, by putting arbitrary inputs in and making sure that the results of the precompile between the Besu EVM and the Geth EVM were the same, were identical, and that was a fairly recent fuzzing based incident report. It seems like more often than not that's for the deep, really technical edge casey type issues that fuzzing has been more productive in finding these problems, these corner cases, potential consensus issues. I don't know if we have access to that. I don't know if those incidents reports are public. I'll look for those and see if I can find those, and if they're public, I'll post them in the chat here. Give me a bit.
Do you know, Gary, if it is with this tool, with TXFuzz from Marius?
No, this one was an independent researcher who maintains his own fuzzing suite.
All right, okay.
That one is used, but that's typically used on DevNets. I don't think that we do differential fuzzing with Marius's fuzzer. It's usually used to attack a DevNet.
Got it. Anything else interesting on the findings? Other kind of area of interest that may drag Whitehead's attention is any kinds of known issues that you have. Those are maybe written somewhere. So if you maybe can cover those, if you have any, of course. By known issues, I mean, of course, bug reports of bugs which were discovered and were not fixed due to whatever reasons.
I don't think we have any consensus issues right now. I think that the Bonsai format we don't typically use that for full archive nodes, but we know about in main, we know that there's a bug that's in the process of being fixed that prevents a full sync from occurring. I'm trying to think. I don't think there's any open security incidents or vulnerabilities we're aware of, or like log4j type things. I don't think that there's anything open for that right now.
Got it. Let me think a bit. I guess these are like the most popular questions from the community most of the times when we run this technical walkthrough calls with projects. Again, if you can, for me personally, and I think I should have added this disclaimer at the beginning, I'm not a technical person, though I understand what you're talking about, but I'm not like directly coding. But for me personally, the Bonsai technology that you described is the most interesting one in terms of like complexity and exploitability. So if there's anything else similar to that you want to cover, and maybe like just open the code and kind of go not like line by line, but maybe cover the main functions, that would be ideal too. So
I'll turn that over to somebody else because I'm not a Bonsai expert, so I wouldn't really be the best to drive through that.
Again, Bonsai or something else. Maybe there was some other functionality that you're proud of.
I think Bonsai, if you start to look at the documentation I sent, will help you to understand the basic part, or more, maybe more, to understand how Bonsai is working. But after, maybe if you have more questions on Bonsai, we can set up another meeting just to talk about Bonsai, because it's really a big topic. And I think maybe if you really need to understand Bonsai, it will need a specific meeting just for that, because if we do that now, I think it will take really more than 1 hour. And I think maybe people that want to understand need to read this documentation before, like that we will be on the same page, and
that's a good point, Karim. Yeah.
Makes total sense to me, of course. Okay, so we can of course link this documentation afterwards. Anything else, gents? Anything else that you want to flag, discuss, cover?
In my opinion, there is also, as I said, the sync for example, SnapSync, because in SnapSync we are receiving a lot of account and slot from the peers, and we also have to verify this account and slot with proof. And I think it could be an attack vector that we will receive some invalid data that will not be detected by Besu correctly and will create invalid state or something like that, or maybe we'll have missing slot or account in the state. And it will be difficult to detect it if we are not touching this slot or account during 1 month, but maybe in 2 months we will try to touch this slot and it will not be in the state. So I think it could be interesting to see if you can just simulate really bad peers.
Yeah, a malicious,
yeah,
a malicious snap peer. Yeah, that would be a good one.
For example, we detected that in the specification, if I remember correctly, when you receive all of the accounts in a range, you don't need to send proof. But we saw that some peers are sending all of the accounts with the proof, and this behavior triggered some issues in the SnapSync and some really problematic behavior, Besu, and it was the result was that some part of the state was missing. So it could be this kind of issue where a peer is not following exactly the spec, and we are not managing very well this use case. So we detected a lot of issues in SnapSync and we did a lot of fix, but maybe there is still other kind of issues still in the code. And I think there is SnapSync, but maybe the sync in general, when we are downloading the block, if we are verifying all of this block correctly, I think it's okay because it's a very old code, but it's still possible to detect something. And I was also thinking about maybe the transaction pool, maybe when we receive some transactions that can maybe block the node or trigger some really complex transaction, and it will be a DDoS attack or something like that. I was thinking more on my side. I was more thinking about SnapSync and transaction pool.
Yeah, that's a good one. And that's dangerous because you could have censorship attacks and things like that, right? So if you can exhaust a mempool, or you can get something to get stuck in the mempool, or take up too much space in the mempool, those can all have ripple down effects where you're denying, denying service to whatever you're attacking.
Yeah, you can create maybe some specific behaviors that will prevent the node to add new transaction. It will not be able to create new block with some transaction or something like that. It could be a problem.
I think we recently fixed a vulnerability in basically blob signature replay for spam attacks. So you could actually censor blobs by masquerading as them with a replace transaction and then dropping it again. I think with the kind of proliferation of new transaction types, and Besu has a new layered transaction pool that is that leads us to build better blocks. We have more capacity to have transactions and have them prioritized correctly, but it is still somewhat developing code. So I think that the transaction pool is definitely a good vector, either for censorship or possibly denial of service too.
Cool.
We have a fairly rudimentary peer reputation system also. I think that might be an interesting aspect. I think Justin kind of alluded to this, that our peering code is one of the areas that we want to refactor, and we're kind of slowly working on that. But we have kind of just a basic rudimentary peer reputation system that affects whether we drop peers, keep peers, search for new peers on the basis of messages and so forth. I think that would be a really interesting avenue to attack if you could poison the peer pool, so to speak, in Besu by exploiting the reputation system or these specific messages that might cause us to drop good peers in favor of poor peers. Like that would be an interesting attack vector.
Yeah. Cool. Let's see. Amezian has made a couple notes in the chat that are probably worth calling out. As far as like traditional remote port type stuff, we're listening on our RPC interface that's user configurable. We're also listening on the engine API on port 8551. We also have metrics, right? So we do Prometheus. Well, we do Prometheus and OpenTelemetry as well. We do both push and polling based metrics. So those could be interesting things to take a look at as far as either pushing metrics to something that was compromised, or polling from them, or poisoning them. Can you get metrics in there that make it look like everything is fine when in fact everything is terrible? Those could be interesting, lower stakes but still interesting ways to attack Besu. Yeah.
Wonderful.
In the attackathon, are we going to be attacking release versions of Besu or something off of main? I could see benefits or drawbacks to both. Like if you're attacking main, you're attacking exactly what's going on. Like if there's any bug fixes that are not yet out in a release. But also if you're attacking a specific release version, you might not be. You are. Yeah. I just it'd be interesting to know. I imagine the attackers would probably attack both the main and the named release versions too.
I believe it's still TBD, but your reasoning sounds reasonable. So yeah, probably it's going to be both versions. Wonderful. Chance, I think this is very good information from you all. Thank you. Once again, final call out. Anything else that you want to add, highlight?
Maybe I can give a general opinion, at least from my point of view. So if I try to think about it, like in terms of security, like the kind of security issues we may have, I think there are in general two kinds of these issues. The first one is related to the core protocol itself, to Ethereum. Basically, some edge cases we don't handle very well, or maybe some gray areas in the specs that get handles in some way, Besu in another way, because we haven't tested that specific case. And these are actually unknowns, because we don't know them yet until they appear, or someone can find a case where it happens. This is what happened with like the self-destruct use case. And in our case, we have reference tests that test different cases to be sure that we handle like some executions as we should do it related to the specs. But yeah, as I said, there are some unknowns, and these tests, like on the Ethereum core, like protocol, are the same for Besu, Geth, Nethermind, Wraith, and Eragon. So exactly the same kind of test we can do, basically simulate some edge cases. And I think the other kind of cases we may have are related to the code itself. Like in this case, we have Java. In Java, we use a lot of libraries. We use of existing libraries, and these existing libraries may have some security, issues. For example, there was a security issue on Log4j. Maybe we are using another library that may have another security issue. Yeah, so this is more related to different dependencies. And there is also our Java code itself. I think yeah, the transaction pool is an interesting one, because we have a new way of handling the transaction pool. We have a prioritized transaction, layered transaction pool. So we have this layer that has only the transactions that should go in the next block. So if we can find a way to pollute that layered transaction pool, so we can basically do some, as Justin said, some censorship, right? So have only some kind of transactions on a Besu node that can go in the next block if that specific node is chosen to build the block. All right, so we have like this this transaction pool implementation. Yeah, so yeah, so I think that's it. That's what I wanted to share.
Thank you. Thank you. Justin, anything else from your side?
Have at it.
Wonderful.
Let us know what you find.
Okay, then let's say that we can end it here. Guys, thank you so much once again for the presentation. Justin, if I can ask you to send me the recording once it's processed. Thank you. So this will be published closer to the beginning of the Attackathon. If I'm not mistaken, the launch date is November 24th. So we're still like kind of a month ahead. We're doing this pretty early. We will also do, like shorts and quotes from multiple walkthroughs for the simplicity of whiteheads to understand the scope. And then once again, this was very helpful. Thank you for diving in. Yeah, and thank you for participating.
Cool. Thanks, everyone.
Thanks.
See you around.
Thank you, John.
Thanks for driving, Justin.
Yep, you got it.